This session is quite interesting because our speaker would take us into a journey that his company went through in moving away from a legacy monolith product to a properly designed distributed system. He's going to share with us all the dirty details, including mistakes they made, problems they ran into, and lessons learned along the way. Our speaker is a part of a team evolving legacy products to the cloud. Outside of work, he leads the Philippine .NET Users Group and is a seasoned public speaker, writer, having conducted community talks, seminars, and training sessions all over the past decades. To talk about Between a Rock and a Better Place, in the middle of the journey from monoliths to microservice, please welcome the principal developer of PageUp, Mr. John Lim Hap.
Hello, good afternoon to everyone, and welcome to this talk that we are going to present this afternoon. And I hope that everyone is still alert and ready to learn, even as it's a late hour. So yeah, so that's a very nice. Thank you for that very nice introduction, Laura. So um, I I entitled this in as Between a Rock and a Better Place, or well, in the middle of the journey from massive monoliths to manageable microservices, and this is not specific to where I am working right now. I'm a principal developer and a tech lead at PageUp, but this is a collection of things that I've learned personally, and I want to just make sure that this is a very personal journey to me. So and we're not yet there. We're not yet in that place where everything is a manageable microservice, everything is a distributed system. But yeah, let me tell you the story of how it is uh, in the middle of that journey. All right. So just a little bit about myself. So yeah, so I'm John. I'm a principal developer at PageUp, and I'm a PSIA Technical Council member, and I lead the Philippine .NET Users Group. So I'd like to invite those of you who have a .NET practice, or who are using .NET in their organization, to join us at Facebook, fb.com/group/finog, or join our meetup. And yeah, we have some events lined up for the next year, and then also check out PageUp. All right, so let's begin this story. I have to clarify that this talk about is about my own journey in learning distributed systems. They're not microservices; is just a buzzword, but their formal name is distributed systems. There are good reasons to adopt it, and there are some reasons not to. It's not just about software development, and all these lessons are generalized and simplified. There are a lot more meat to them than I will reveal here, but I hope that by simplifying them, it makes it easier for people who are considering getting into turning their legacy products into microservices, or their companies evaluating this direction. It might help those people. All right. Moving on. All right, my cursor is refusing to work. Give me a moment here, please. This talk is not about, oops, we jump over a few bits. This is talk about is, I'm not going to say monoliths are bad. There, and in reality, it's not that monoliths are bad. It's how they are designed that can be bad. So nope, you're not going to hear that. Neither are you going to be convinced that to use microservices. If you've heard about it, you probably heard about all the good things and all of that. But yeah, with those good things, there are some caveats in my story later. It's not about any specific cloud service. So whether you're using AWS, Azure, or Google Cloud, or some other platform, we will be talking about that. And then I'm not also going to say anything specific to my all right, everything that I'm going to say here is my own opinion. They're not my employers, so take it with a grain of salt. And it's not. And while I'm promoting PageUp, it's not specific to them, and it's not their specific opinion. Okay, so my previous experiences when building new software, and I think many people can relate to this. Of course, as disclaimer, any similarities to persons and companies existing or defunct is purely coincidental, but it's not necessarily fictional. Okay. All right, so we think of monoliths, diba? Actually, the word monolith right now is popular because of those things that are appearing in the middle of the desert in Utah and in Romania and all over the place. But and we think of them as these big hulking things. And some of our apps do feel that way. Some of our ERPs specifically look like these large, impenetrable fortresses of code, right? But in reality, a lot of them simply started out as, let's say, think of apps as a house, right? You have a plan for you, and it's usually laid out by a project manager, well, a software architect. It's a structure. So you're going to start with saying that I need an app that has four walls, a roof, a door, and some windows. And that's how most people start. And sometimes it's a full app. Sometimes it's, just a little more than an MVP, a minimum viable product. And that's how you want to start out. So in the days of the waterfall, you start out with a plan like this, and on the day of the release, of course it's not done yet. So this is the usual, the usual experience. But yeah, just really kidding about this. You will finish it eventually, and it will become this thing. But then you try to sell it to customers, and they will all want different kinds of features. They will want this, that, and that. And because of accommodating all those kinds of features, this is what your app looks like today. It becomes this is your typical legacy app, which is a hodgepodge of different features with different implementations, different technologies, and different things that are they try to communicate with each other. And it won't be, in many cases, it won't be perfect. You try to sell these to your customers, and they will say it's ugly and it's slow and it doesn't work on my iPhone or things like that. But yeah, when you talk about, all right, what will it take you to buy it, and they will ask for a new feature, something related to artificial intelligence, for example, or machine learning, right? And they also need a discount. So that's just the reality of the business. That's just how things go. The problem with this approach is that while it works while your application is small, I have been in organizations where it started just falling apart, right? We fall into a cycle where, to be able to sell the application that we want that we want to give clients, or to be able to onboard a client, they will say, oh, we will onboard with you as long as you implement X feature. The problem with that is because you've already put in so many things differently into that thing. Once you put in another feature, you have to make sure that everything else works the expected way. You have to make sure that that new feature integrates with those things, and then you have to put it in. And if you're your application is less than ideally architected. I have been in organizations, so two different organizations, not just my current work, where they had been in a situation that to implement a few new feature for a new client that they are talking to this week, that client has to wait for 2 years, 2 years, 3 years, just because the pipeline for adding a new feature is that long. There had already been a client that said that, hey, we're going to onboard with you, and it's a big this big corporation, and but we need this, and this, and then you estimate it, and even with big companies, sometimes that takes 6 months, sometimes that takes 1 year. So this is a very common situation, and I have encountered this not just once. I have encountered this in several companies. So that is the cost of the technical debt that those features are. So to be able to add more features, we try a different approach, right? We try to make our product coherent. We have to distribute the application, and this is when we start entertaining the concept of having microservices, having distributed systems, and to be able to do that, however, we do have to recognize that, yeah, we need to decouple them from the application. We need a way to separate it without the whole thing falling apart. And that's where it becomes difficult for developers specifically, but even technical leadership, to convince their superiors or the business. How do they convince their uh, their leadership and their management to even try this thing? So what I'm going to present to you are, some of the lessons from efforts to decouple and distribute in workplaces past and present. And again, these are from my own perspective, and I hope that some of these lessons will be invaluable for you. All right, let's proceed to lesson 0. Of course, I'm a programmer. I start things with number 0. So, lesson 0. The thing is, you're a programmer, right? But software development is a business, and it's not just a technical change. Um, it's difficult to convince a lot of organizations to even try the cloud, right? But then try them to convince them to even take a microservice approach, or take a containerized approach, or do that with a legacy app. It's not easy. You have to justify. We need a new architecture, and from their point of view, it's not broken. That's not what is broken. The app is slow. The app is big. Throw money at it, and that will solve that problem. But to be able to convince them that no, actually, we have to do things differently, that's an altogether different conversation. And the key thing to understand here is that you have to give them a good reason, a kind of a promise. And this is an oversimplification. It will take 6 months instead of 2 years. But this is necessary to make them understand that there are investments that you have to make to be able to roll out features and come out with a new product faster. So the gist of that lesson 0 is that it's not just about the technical change. Your organization must have a clear understanding of the impact of technical debt. Okay. Your organization must have they must be able to quantify technical debt. How much does it cost you not having this contract? How much does this cost uh, you in developer hours, on extra developer hours, on manual deployment, or smoke testing, or just regression testing, so that any improvement that you make, or any change in your architecture, is seen as an investment. And reducing your technical debt must have a clear business value. Now, for the developers here, this might not be it might not be obvious to you how to do this, but for those who are moving up to management, or those who are in the architect types, or the CTO types, they would have a sense of this already, because everybody works with a budget. And being able to justify technical changes, so that changes in budget, or improvements in budget, can be done. That's something that you can take up with the business. All right. Okay. So let's move on. Give me a moment here, and let's move on to our second lesson, lesson one: decouple your data. Now, let's say that services. Of course, you won't be able to do it in, overnight, chop up your application. It's already big, right? So one strategy that people do is, okay, the next thing we implement, or the next improvement that we make, or the next feature that we add, we'll turn that into a microservice. And yep, that happens. But the thing is, initially, what you don't think about is that monoliths have a data store, and all your monolith data is usually there, right? We know of big applications having this big gigabyte, terabyte level databases, usually in some large RDBMS, and all the relevant data that any feature that you're going to make will be there, right? So you write up a microservice for the first time, you deploy it by itself, but usually the first thing that people does is, all right, I will need to have the data from my existing system. So they connect their data to their existing system. They connect their data to their existing monolith. And all right, well and good. That looks fine for now. Just to test the concept of microservice, and then you start building other microservices, and more and more and more. The thing is, you also forget that, oops, all my data is right there, so let's just connect it there. And you connect it to the same data store, and now all your microservices and even your monolith is connecting to the same data. Congrats, the data store is now your monolith. And this is often called as a distributed monolith. Basically what happens is that any performance lag, any performance problem would usually be rooted in the fact that everything tries to connect to the monolith, and your transactions are backlogged, and you don't really get the advantage that you were promising the monolith would have. You said it will perform faster, but yeah, it can only perform as fast as it can get in write data, right? So so what will happen there is, how to solve that is, your microservice should have an independent data store. There's a lot of possible formats, rather, of what kind of data store you could use. You could actually use another RDBMS. You could use a document DB, other NoSQL types like key value stores, GraphDB, uh, etc. Um, Depending on what is appropriate for whatever microservice you are making. And this is a longer discussion. This is a longer discussion on concepts like bounded context, and having source of truths, and all of that. But the first thing that will pop out as a question in any discussion when you say that, yes, I'm going to make independent data store for my microservices, that how do we maintain the consistency? Now, that is a complex question to answer, really. One of the things that you can do, for example, in a short to medium term, is having an anti-corruption layer. An anti-corruption layer is a microservice. Well, not necessarily in this particular illustration. I implemented it. It's an implementation of an anti-corruption layer as a microservice, and it will periodically synchronize the contents of your monolith and your whatever microservice you have, right? So in the short term, this is one way to do it. It can be a what do you call this? It can be a timed or a cron job type of thing. It can be done real time every time the service is accessed. But what's important is that you will be able to enforce eventual consistency in yours between your monolith and your microservice, to make sure their data are consistent with each other. So that's your short or medium term thing, or solution rather. um in the long term, and this is the bigger study that is needed for most people, having an event driven system, where both the monolith and the microservice publishes events, and those events say what changes happened in their system, what data was created, what data was updated, what data was deleted. Basically, your CRUD operations, but basically anything that you need to inform the monolith that, hey, this happened, this user was created, this user was deleted, this change was made into this particular record that you're doing. It will be published into, say, an event, usually an event bus, an event pipeline. In AWS, you could do it via simple queue services, SQS, and simple notification services, SNS. Or you could use their newer event bridge. In Azure, they can do it using event hubs, or I think there's the event mesh. I forgot the Azure equivalent. But basically, the whole concept of those implementations are the same. You publish changes to your data to that mechanism, and then there are listeners to those systems. In the beginning, it would probably just be between a few microservices and your monoliths, but eventually even other services can either consume the same events, or you can make individual event pipes or event buses for between other microservices or between monoliths, depending on the concern that you need. And and the key there is that you only listen to the your services only listen to the ones that they are concerned with, right? So this is a much longer discussion. And I encourage everyone to read more about domain-driven development, bounded context, patterns of distributed systems as well. The things like CQRS, things like, yeah, the anti-corruption layer, the event-driven systems, and this is such a wide topic. This was such a wide topic that needs reading, but its understanding will be key to successful distributed systems designs. Right. Right. Let's move on to our next thing. lesson 2, think async. This is a little more personal in a way, because this story is something that happened to our team, the team I have in PageUp. So as humans, even though events happen to us asynchronously, I mean, I'm speaking here right now, but my 3-year-old boy is actually trying to knock into my door and looking for me. But those things do not happen in sequence. They happen at the same time. They happen separately. But when we tell that story to someone, right? I'm talking in softcorn right now, and then my kid is knocking on my door. It's like it's a sequential. Step one, this happened, then that happened, then that happened, and that's just how we think, and that's how we tell stories, and that's how we evolve as humans. So it's probably logical that sometimes when we program and we have a problem, we also try to solve it in a synchronous way, and tell the story step by step. So, for example, in our team, we had to make a microservice, or we have a microservice that interacts with a third party service, and we have to redirect our users to that service, passing through a monolith, going to our service, then going to that third party service that we're linking to. And when we implemented this, it's but natural for us to think of it that the user interacts with the monolith, and then the monolith interacts with our service, and then we make a call to the third party, and then the third party gives us a response, and that response gives us enough information to redirect our user to the third party. The thing is, we were working on a recruitment system, okay, and I won't disclose what kind of third party services were there. We just need to redirect them there. But there was a client that had a recruitment push, or a hiring push, a massive recruitment campaign. And it's COVID-19, it was the pandemic. There's a lot of people who need jobs, right? So there's a few hundred people looking at the recruitment system, and they need to go through this because this is a requirement for their recruitment process. So the response, unfortunately, when they click on submit for or start, or whatever it was, um yeah, the whole round trip for that sequence of jumps from the monolith to our service to the third party, it took more than 10 seconds. The thing is, humans are, you know, hu- humans are impatient, and especially in computer systems, we think of it as they respond fast. And yeah, we didn't really imagine that, okay, here's the problem. It because it was taking 10 seconds, and then there were 50 users, maybe even 100 users at the same time, trying to click that submit button, trying to get it, because yes, I need a job, I need the job now, I have to get to this, through this step, and open that third party site so that I could submit whatever requirements I needed. What do you think happened to our microservice? Of course, boom, it just collapsed out of the weight of all those things. And the and the funny thing there was, we ourselves tripped on our own code, because we had a retry mechanism that was also flooding our own system with retries of the request, and it just didn't handle it. And we had to, take a step back and ask ourselves, all right, what's the problem here? And the problem, and one of the problems at least, was that the user didn't have a loading page when we were making them wait for the refresh, for the redirect to happen. But while that was happening, the screen was blank. So naturally, they thought that, oops, I didn't do anything right. I'm facing a white screen. So they click the back button, and they click the submit button again. So we had to think asynchronously. When we when the user says click, and then we get notified that, hey, this user is trying to get to that third party service. We first redirect them to a loading page, and then we call the service, we wait for the response gets to us, and that's the only time that we redirect the user away to the third party. So a simple you know spinny spinny animation. This is not the exact one, but just that response, that to tell the user that, hey, we're doing something, please wait, is enough for it. And while this is specific to UX, right, there are many similarities to this when you enter, when you implement your own microservices and distributed systems. And sometimes it's just a matter of telling them that we're doing something in the background. Uh, 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 Please wait. So um, the other benefit, the other thing about having to think of that asynchronous experience is that it's still about decoupling. It made us decouple our processes and our thoughts from the initial monolith implementation. Both the monolith and that third party that we're calling, we were tightly coupled to them, just waiting for their responses synchronously, right? So, um, turning that into an asynchronous experience made it more decoupled, and then it became an opportunity to improve that user experience. All right, let's move on. Let's move on. All right, the next one is about manageable microservices. Because it's really the thing with microservices is that it's easy to try to turn everything into a microservice, and then it just becomes unmanageable because you have so many things out there. And in the beginning, you only have one microservice talking to your monolith, and they have a request and everything, right? But eventually, when you have more, there will be a lot of them, and sometimes the microservice will be the monolith will be overwhelmed. Sometimes it's simply just that chattiness, that back and forth, even with those anti-corruption layers that you have. Just having too many of them going back and forth, that's number one. That's um your network would be flooded, and there's a lot of it. And you might end up with just another monolith, just two big balls of mud. um for example, some of the things, one of the stories that I could share is that when people were talking about how to best log events, or best make error logs or such, so that support can easily respond to things that are happening outside the monolith. So um, um, a support team can have the implementation of error monitoring and all of that in a monolith. But that would mean that all your microservices will try to talk to the monolith to report errors, right? Which is might not be the best way to do it. And if there's just too many microservices with the same concerns, and they're all over the place, you end up with two big balls of mud. And seriously, we're back to square one. We're just back where we started at the beginning. If you have whether it's a mis poorly architected monolith that just tries to do everything, or it's a ton of microservices that are trying to do some of the same things, and not doing things efficiently, and just there's no clear direction how to manage them, there are different ways of deploying them, there are different ways of testing them, there are different deployment cycles and things like that. It becomes difficult, right? So how do we manage that? The thing is, each microservice that you implement, you will notice a repetition of recurring concerns, right? um, you need to be able to have communications, whether it's to your users via email channels, via chat, etc., etc., or communications to other systems like an API layer, or yeah, other forms. All of those would have security concerns, and being able to shield itself from attacks. All of them will have observability concerns, logs and alerts, and things like the things that say that your service is healthy or not, right? Things that indicate that. And data portability, being able to export the data so that other systems can make reports out of it, for example. You will have recurring concerns, and that this is a good starting point to kind of organize your services. The solution is to try to organize around those recurring concerns and treat them as capabilities. Now, for the rest of what I'm going to talk about, please read up on business capability models, because that's where this is based on. So you have these recurring concerns. You treat them as capabilities: the communications capabilities, security capabilities, observability capabilities, and data portability capabilities, for example. And um, this is actually one level of capability. They're probably best called as platform capabilities, because they are a platform that is needed by the rest of the business. But yeah, in my current organization in PageUp, we have four levels of these capabilities. We have foundational capabilities at the bottom, which is your infrastructure, your CI/CD, which is your continuous deployment and continuous integration, and then storage and backups. That's one level of foundational capability. These are your building blocks. And from these building blocks, you make platform capabilities, which allow you to address those common concerns. And then on top of those, you could build your business domain capability, your specific area of business. I'll explain later what that could look like. And then on top of that, you have your UI layers. You have your microservices, whether they're APIs or their web apps or their mobile apps. That's your experience capabilities. And some teams will be dedicated to the foundational and for platform capabilities. So these teams would take care of these capabilities, so that whether we're talking about infrastructure, that's infrastructure as code, building your your cloud services. Usually this is applicable to cloud, or just setting up your CI/CD, what the best practices are, etc., and then putting in the tools for that. One team is taking care of that, and then other teams will then be focusing on specific business domains that will be able to leverage whatever is built in the foundational and the platform area, and then out of that they would be able to create experiences on top of that. So think, for example, of a site like e-commerce sites like Lazada and Shopee, right? They would usually have, in a simplistic way to model their them in this business capability model, will be like this. Your business domains are sales and payments. Both your sales and payments would have those same concerns: communication, security, um, observability, data portability, um um sales would be more focused on collecting data so that they could get, they could run their data through machine learning and get buying patterns. Payments will be more focused on security and making sure that all your transactions are they push through with whatever they're integrating to banks, online payment services, etc. And then on top of those business domains, you have mobile apps. You have on the sales side, you have your mobile apps. You have your social media integrations. You have your uh, website store. And then for the payments, yeah, they might be integrated in mobile payment setups, um or they might even be integrated with a physical POS, or they have APIs that they can use to integrate with banks. So that's how, uh, one example of how to organize around capabilities. So just to recap this story, right? So far, so good. We're still learning the lessons at my current organization, um, and there's still a lot of things going on. It's not a perfect implementation. It's easier to have some implement some things more than others, but yeah, it's still ongoing. The process of learning from this is ongoing. And I have to say that it might not make sense depending on company size. If your company's too small to even have separate teams to handle those things, then you'll have to have a, more 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 aggressive prioritization cycle, or you have to, make amends on how that responsibility, make compromises on how those responsibilities are divided. All right. So, in summary, it's about reducing technical debt to drive up business value. Anything that you do, re-architecturing your systems, or making, trying out a new software development paradigm. It's all about business value. You have to justify it, in terms of how it can make your business better, and that will just make conversations with your leadership easier. um decoupling decoupling from monoliths involves leveraging different patterns of distributed systems design. That's another lesson. And again, please read up on it. There's a lot of resources online about these things. And then leverage these designs to improve user experiences. At the end of the day, if your user experiences aren't improved, they won't care if you have the latest and greatest uh, containerized deployment thing. If the user experience sucks, it's all for naught. The next lesson is the next point is asynchronous operations and event-driven designs are key to inter-service communication. So these are, you have to always think that you're not making another monolith. You're actually making, a lot of different services that are separate from each other, and you have to think of them aside from your own service every single time you make another one of them, especially. And then finally, organize around business capability models. So that's one good way to organize what you have in your organization and organize your teams, so that it's clear whose responsibility it is to take care of things. And it's just planning out the investments is also easier when you're organized well like that. All right. So that is the last slide in my talk. Thank you very much, and I hope that I hope that you learned a lot. So that ends my talk. Thank you very much, Lawrence. Yeah, we can take in questions now.
Okay. Thank you, Sir John. Thank you for sharing your story of your company. I'd like to think of for virtual applause for now.
Hmm.
Also,
Yeah, thank you.
sir, I'm gonna read some questions directed to you. So,
Sure. Hmm.
first question is from Vincent James Pass of Ernie Development Center.
Hmm.
Based on your experience, is it a bad or great idea to use different programming languages in a microservice architecture?
Um, in our organization, there are actually teams that use a different language than other teams, and that's but usually the choice of language is because number one, it's the best language for that job, right? That should always be first and foremost. Number two, you have the skill set to take that on. So it's okay to have different languages, and you will have to learn a degree of different languages. I mean, because of some of our infrastructure is written in TypeScript, for example. Even if I'm a C sharp guy, I occasionally have to read and study TypeScript. So even if, so it's possible, it's doable, but you have to have the resources for it.
Okay, thank you, sir, for that answer. We have another question from Edwin Abaniel of NDS Call Solutions Incorporated.
Mm-hmm.
These are three questions, by the way. First question
Mm-hmm.
was when to use the best monolithic and microservices architecture.
Mm-hmm. Um, Monoliths are not bad in the sense that if they're medium-sized, small to medium-sized applications, and they're well designed, yeah, they can still work. In fact, you could theoretically have monolithic services that are communicating with each other, and that might be your distributed architecture. That's possible. In my experience, I think that the monoliths that are easiest, or the parts of the monolith that are easiest to um architect a way into microservices were actually well architected already as monoliths. So that means that siguro demands, just the demands of the application loads were the key decision point in separating it into a separate service. But if a monolith is well written, it's actually not a problem. So that's something that you need to understand. Yeah.
A part of his question was also, do I implement microservices with the same with the database or DB?
In my slides, I did encourage everybody to have one data store per microservice, and the key concept that you need to understand here is that data store for that specific microservice is the source of truth, meaning it's the primary holder of whatever information that service needs. So that would mean that the monolith old database, that would be secondary. You would need that. Number one, you would need that kind of architecture, and then number two, this is a larger discussion. You would have some sort of tenancy strategy that you have to implement, because of course you will have different clients, and somehow their data has to be separated. So sometimes it's as easy as having a separate client ID or a tenant ID. Sometimes it's having shards, different shards of the same database, and the different microservices being implemented per or being deployed per shard. That can be difficult. There's a bunch of ways to, and I really don't have time to discuss all those different ways, but that's a topic in itself altogether. The point is each microservice must own its data store to be effective.
In terms of database for microservice, which one is better, SQL or no SQL, or does both of those can handle the database?
It depends on again. It depends
Depends on-
on the context. So many microservice implementations actually use NoSQL. They use either document DBs or key value stores. In AWS, a popular choice is Dynamo, for example. So Azure, it's Cosmos, and it's better to stick to to stick on that, but you have to have a determination on what your use cases are. I mean, each type of database is best for a specific job. So for example, if you're doing a social anything that involves social networks, for example, uh you'd want a graph db because graph dbs are best for relationships, mapping relationships from one to another. So think you have to take those into consideration. So there's no straight answer on whether it's no SQL or SQL. It you have to consider what are you doing in that particular microservice.
Okay, so our last question would be from Jed Alado. Based on on the event-driven system diagram, so
Mm-hmm.
there'll be two database that each monolith and Microsoft will access.
Mm-hmm. Yes. Again, it's not just two. If you have a specific if you have several services, you have 10 separate services in your monolith, that means each service will have its own data store, and then your monolith also has its own. And that sounds overwhelming, especially for people that have been used to RDBMS being just this one big entity. But in reality, if you try to look at your big system and look at your tables, a lot of the tables aren't related to each other. They don't even have keys. And some of them can be isolated. If you map the relationships, some of them will be isolated by themselves, right? Except for probably a user ID that maps to another part. So that will give you a clue on what the separations actually are and what can be separated into a different service in a different database. Because yeah, I mean, I've seen 100 tables, 200 tables, 1,000 tables in some RDBMSs, and a lot of them really they don't relate to each other. And that's and where those divisions lie. That will give you a clue on what the separations should be and how many databases you actually can have.
All right. Thank you, Sir John. Thank you for answering those the questions that we have for this live session. Now, I know you all have some questions for our speaker, but you
Mm-hmm.
can send those questions through his private chat
Mm-hmm.
through our portal. And also, sir, I'd like to ask for a quick photo op so that we can document for this event. So just
Sure, sure.
so right now, I'd like to ask for you to smile into the camera.
All right.
One, two, three. All right. Thank you,
All right.
sir.
Thank you very much. Thank you for having me, and I hope the participants here learned a lot.
Yes. So